Hello once again. Here we are with the metric measuring refresher. Don't grumble, your brain has been on vacation a long time. All right, so this is a nice little reference set of notes to help you remember how to measure. We just did a set of notes on metrics and how to just use the metric system, but now here we really need to get into the skill of just learning how to measure correctly. So once again, we don't use the English system. We don't use inches or pounds or gallons or miles because it just doesn't work out nicely. You can't use the decimal system with it. You get into like eighths and sixteenths and twelfths and just weird things like that. So it's just a lot easier for us to use a metric system in science because we can convert it mathematically so easily. So that's why we use things like centimeter, kilograms, liters, kilometers, or meters. There we go. All right, so first of all, when we're using a meter stick or a ruler, we always want to check the end of it for imperfections because you and I both know that you like to pound the ruler on the desk or really just destroy anything you can get your little grubby hands on. And sometimes those ends are chipped off and it's hard to see. Now then, if your ruler has a zero mark, go ahead and use it. But make note that the very end of the ruler may be even beyond the zero mark. So you want to use the zero mark, not necessarily the end of the ruler, and usually not the very end of the ruler. If your ruler is beat up, you might want to start at the 1 centimeter mark and then subtract 1 centimeter from your measurement at the end. Also, you want to make sure your ruler doesn't move. That wouldn't be good. All right. When using any measuring instrument, you always want to look straight at the marks. You don't want to look down at it or up at it because it can change how you see it. Just the other day, my son thought that my gas tank was almost empty and he was yelling at me because he thought my gas tank was empty. And I said, "No, Luke, it's just your perspective." He was looking at it from the side and it really wasn't empty at all. So problem solved. So for example, on a graduated cylinder, it can be helpful because it's clear to hold a piece of paper behind it to better see the meniscus. And remember, the meniscus is the curve. Okay, kind of a curve. No, really, it is a curve when it's liquid that the liquid makes inside the cylinder. And we always want to measure from the bottom of that meniscus. My drawings aren't that great, so bear with me. All right. So on any instrument, once again, very important. This is really, really important. We want to estimate one place beyond what we know. And that is just accepted practice in science. And this is what we call significant figures. And this points to the precision and accuracy of our measuring instrument and the accuracy of our measurement. Okay? The precision of our instrument and the accuracy of our measurement. So in other words, when another scientist reads my data and my data goes out to the hundredth, that scientist knows, now listen, if my data goes out to the hundredth, the other scientist reading it knows that my instrument has a last known mark to the tenth. We're speaking the same language when we measure, okay? Now then, if I am maybe, I don't know if two scientists are kind of competing and maybe another one has a data that's recorded out to the thousandth, then they have a more precise measuring instrument than I do because that means their last known mark was at the hundredth. And we'll talk more about what that means coming up. So, estimating, here's a refresher. And again, this really is all about something called significant figures. Okay, and these are the numbers that are significant to a measurement. Okay? Significant figures, and you will definitely hear more about these as you move on in your science career. Okay, significant figures, that's an R, not a V. Okay, significant figures. So let's look at what is on this slide. So we have a 0 mark and a 1 centimeter mark. So this would be a way magnified ruler. Okay, and I have a red mark here in the middle. Okay, and we want to know, where is the red line on the box? So take a minute and guess. You are so smart. That's exactly right. I would say it's about the halfway point from 0 to 1 centimeter. So if we were to say that in decimals, what would that be? You are exactly correct. It would be 0.5 centimeters. Way to go. So here's another one. Let's say our mark is really close to that 1 centimeter mark. We might say it's in between 3/4 and the end. But in decimals, we could say, I agree, that's what I would say too, about 0.9 centimeters is what I would say. But remember, these are estimates, so you might have said 0.8, although that's pretty far down to be 0.8, but that would probably still be acceptable. That estimated number, it's not as critical that it is absolutely correct. It can't be, because it's an estimate. But again, it's showing someone that my last known mark is at a whole number. So let's try this on a ruler. There's our little Mr. Woolly. He's so cute. And we want to know how long he is. So there is 1.1, 1.2, 1.3, 1.4. Okay, we would probably say he's right at 1.35 centimeters, because we can estimate that in between 1.3 and 1.4. So even if the line is dead on, we still need to estimate one place value. And again, that's just to show the accuracy and precision of our measuring instrument. So this appears to be dead on 1.1, 1.2, 1.3, 1.4, 1.5. Okay? So we're going to write that though as 1.50, because if I left that alone at 1.5, what I would be telling anybody who's reading my data is that I don't have these little marks, that I've just estimated this to be 1.5 kind of somewhere here in the middle. But no, it's exactly on that 1.5 mark, and we go, our last known mark is to the 10th, okay, and we estimate one place further. Okay? And this slide goes into more detail on that. So again, it's not precise and probably not accurate. Okay, it could show a range of possibility, again, between 1 and 2 centimeters. To estimate one place further is the accepted practice, and it shows the precision of the instrument. At 1.50, I know that the instrument is marked to the 10th of a centimeter, or we could say millimeter marking. Okay, but we're doing our measurements in centimeters. This is probably one of the most confusing things to start off the year, is trying to understand how this works. But we just need to remember we estimate one place further than our last known mark, and this is called significant figures, and it points to the precision of our measuring instrument and the accuracy of our measurement. And we want to communicate in the best way we can with our data. Okay, so here's some practice. Okay, and again, this is significant figures, so the rule, whenever taking a measurement from an instrument, you should always estimate one place further than what is shown on the scale. The picture to the right shows an arrow pointing at a reading that's to be taken from some instrument. Every tenth of a unit is marked on the scale. Therefore, we should estimate to the hundredths place. So we would possibly say that this is 1.53 units. If you would put 1.5, that would not be correct because you can see it's a little past that. And if you'd put 1.6, that would not be correct because you could see it's not quite that far. Therefore, I estimated to about 1.53 units. I can't estimate further to the thousandths because it would be impossible to see that. Okay, you'd be estimating an estimate, which you really can't do. So now what I would do is probably pause for a moment, and as you look further down at your note page, you're going to see that there are some more practice problems. And try those on your own, and then let's go back and check. So please hit pause. Thank you. Welcome back. So let's look at this one. It says, what does the scale to the right read? Well, let's look. It looks like I'm going to the tenth of us, must be a centimeter here. So I'm at 3.1, 3.2, 3.3 is right here. And it looks like I'm just a little bit before 3.3, or yes, 3.3. So I'm going to say that I am at possibly 3.2, and I'm a little bit beyond the halfway point. So I'm going to say that I'm at 3.27 centimeters. So if you got somewhere in that neighborhood, that's pretty good. So you could be like 3.26, 3.28, and that's okay. That estimated digit, again, it's not critical that it's correct because it can't be. It's estimated. It's just critical that you have it there so we know that our instrument goes to the tenth of a centimeter. On this one, it looks like we have degrees Celsius, and there's 20.1, 20.2. So I'm just before maybe the halfway point in between 20.2 and 20.3. So I'm going to say that I am, oh, I'm sorry, that's 21, 20, Mrs. Hiatt read her scale wrong, so I guess that's a good thing to point out here. That's 21, 22, 23, 24, 25, because that's 30, so it's really important that you look at your scale. Mrs. Hiatt wasn't paying attention. Okay, here we go. So let's look at that again. We've got 22, probably about zero point 0.4. So that's just telling us that we're at the whole degree there. That's our last known mark. Wow, I almost got that one wrong. So 22, and I'm going to say 0.4 degrees Celsius. And again, not that critical that you, on that estimated digit, you might have said 22.5, you might have said 22.3. I'm going to go with 22.4. Number 3, we have, it looks like we're at 1, and this is a gram scale, so that's 1 gram, and we've got 2 grams, so that's going to be 1.1 grams, 1.2 grams. So I'm going to say that's probably like 1.15 grams. And there it is. All right, and then the last one on your practice is reading a graduated cylinder. And this one's kind of confusing because that's not the best picture in the world. So I'm just going to go ahead and say the very bottom here, where we see that line, is going to be the bottom of your meniscus. Okay, so about right in there. Okay, now on a graduated cylinder, these can get kind of tricky. You usually have this big line that goes all the way across, and that's to tell you that's the 50 mark. Just like this line all the way across is the 60 milliliter mark. Okay, so this little line kind of halfway through, that would be at 55 milliliters. So these are going up by 1 millimeter markings at a time. And it looks like my mark is just right here below 53 milliliters. So I'm going to say that that's like 52.5 52.8, I think. Somewhere around in there. And again, this could be 52.7, 52.9, something like that. Okay? And that would be fine. All right, hopefully you understand how to measure a little bit better after doing this practice. Good job.